Today you're going to be learning about what are zeros of a function and what are x and y intercepts on a graph. Let's start by looking at a real-life example. Angela has 200 prepaid minutes on her cell phone. She talks to her friends for 25 minutes per day. So this is a function given to you as a word problem. The question that we're going to be looking into answering today is, after how many days will her prepaid minutes be gone? Okay, so let's look at some different representations of Angela's cell phone plan. First of all, we can look at it as a function written as an equation. That would look like this. F of d equals 200 minus 25d. Because she's starting with 200 minutes and she's using up 25 of them every day. Let's also look at a table of values for her function and at a graph. Here's a table of values showing how many minutes she'll have after each day goes by. So after 0 days have gone by, she has 200. After 1 day, she has 75, and so on. And you can see eventually she's going to run out of minutes. We can also look at that on a graph. On this graph, the x-axis is representing her input values, or the number of days that have gone by, and the y-axis is representing how many minutes she has left. So you can see here where 0 days have gone by, she has 200 minutes. And then each day, that's decreasing by 25, until eventually she's going to run out. So the question we were asked was, when will she run out of minutes? So it's possible for us to see that in a number of ways. One of the ways we can see that is right here on our table. Here's where she runs out of minutes after 8 days have gone by. We can also see that on the graph. Here's where she runs out of minutes on the 8th day. That's when she has no more minutes left to talk. So in both of these cases, we were looking for the zero of the function. The zero of the function is when the function value gets to 0, when the thing we're looking at, when the output value becomes 0. You'll notice that on the table, it was under y, when the y value is 0. And on the graph, it was also where the y value is 0, or where we are on the x-axis. Okay, so what is a zero of a function? Let's get a definition. A zero of a function is the value of the independent variable that will make the value of the dependent variable equal to 0. In other words, since we have lots of names for these variables, in other words, you could say what input would give an output of 0, or what x value would give a y value of 0. The important thing to remember here is it's not the input that's 0, but the output. We were looking for when her cell phone minutes were 0, not for 0 days. Okay, so how do you find the zeros of a function? Well, it depends on what you're given. If you're given a function as an equation, what you have to do is set the dependent variable equal to 0 and solve. By solving, you'll find what input gives you an output of 0. If you're given a graph, then that's different. That's like the graph we looked at for Angela's cell phone minutes. And what you want to look for is where the graph crosses the x-axis. At that point, you have run out of, in that first case, minutes, or in other words, your y value is 0. Your output value is 0. That happens where you cross the x-axis. Okay, so let's take a look at some functions we're given as equations and talk about how we would figure out what the 0 is for each function. Okay, so for number 1, again, to find the zero of a function, we're looking for where the output value is 0, or where the dependent variable is 0. And in this function, x is the independent variable or the input, and g of x is the output or the dependent variable. So I would say here, let's see what happens if I make the output 0. So if I make the output value 0, I can solve now for the input value. Add 12 to both sides. I end up with x equals 4. Using symmetric property, I can flip that around. So that tells me the zero of this function is 4. The x value 4 will give me a y value of 0. Let's try number 2. If you'd like to, you can pause the video, try it on your own, and then double check with me. Okay, so again, I'm going to put the output value as 0. And now my goal is to solve for what input would give me an output of 0. So to do that, I'm going to subtract 16 from both sides. And then divide by -5. Now, this time it did not work out evenly, and that's okay. Remember, if we have a negative over a negative, they cancel out. So I end up with the 0 of this function is x equals 16/5, or you could say that's 3 1/5. That's how you find the 0 of a function if you're given the equation. Okay? The other thing that we want to talk about are the intercepts of a graph. Okay? There's two kinds of intercepts. There's the x-intercept. The x-intercept is the point where the graph crosses the x-axis. So if I give you back Angela's cell phone graph, remember she started with 200 minutes and then slowly decreased her number of minutes each day. The x-intercept would be this point here. This is where the graph crosses the x-axis. So if I wrote that as an ordered pair, that would be the point 8, 0. Even if it crossed the x-axis at a different place, anywhere that it crosses along the x-axis, what's always true about that point? Well, it's always going to be something, 0. Okay. The other type of intercept you'll see is the y-intercept, and this is the point where the graph crosses the y-axis. So that happens up here at 200. If I write that as an ordered pair, that coordinate pair would be 0, 200. So wherever it crosses the y-axis, what will always be true about that point is that the x value will always be 0. So it will always be 0, something. Okay, so let's look at a couple of examples. We're looking for the x and the y intercepts. Okay, so for number 1, let's start with the x-intercept. The x-intercept, again, is where the graph crosses the x-axis. So I'm looking along the x-axis, and it's crossing the x-axis right here. And that point, I need to give it as an ordered pair, is -3, 0. Then if I look for the y-intercept, I'm looking for where does the graph cross the y-axis, and that happens here. So the y-intercept is the point 0, 3. And again, I give that as an ordered pair. Okay. If we look at number 2, if I'm looking for the x-intercept first, I'm looking for where does the graph cross the x-axis. Well, actually, for this curve, that happens in 2 places. That happens in two places. There we go. Here and here, which means I can have two x-intercepts. This one would be at negative 4, 0, and at 2, 0. And then if I look for the y-intercept, I look for where does it cross the y-axis. That happens here. And that's 1, 2, 3, negative 4. So that's 0, comma, negative 4. Okay, so let me ask this question. What are the zeros of these functions? So if I think back to what we started with defining was what's the zero? The zero is what input has an output value of 0. So for graph number 1, the 0, remember we look where the y value is 0 is along the x-axis. So the 0 would be negative 3. And for this graph number 2, there's two zeros, negative 4 and 2. So what are the zeros the same as? Well, the zeros are the same as our x-intercepts. However, when I'm giving the x-intercept, I give it as an ordered pair. When I'm giving the 0, I just have to tell you what's the x value that gives an output of 0. So the 0 is just negative 3, whereas the x-intercept is the ordered pair, negative 3, comma 0. All right, that's it, and we'll talk more about this in class on Monday.